we want to design a circuit that will behave like this. We have 4 states, state 0, 0. Your output is 1 here for this state. This is 0, 1. Your output is 0. This is 1, 0. Your output is 1. And this is, I should lower this, 1, 1. Your output is 0. Let me lower these just a little bit, just this one. Give me more space. 0, 1. Your output is 0. And if you put a 0, you want to stay there. If you put a 1, you're going to go down to this one if your input is 1. If your input is 0, you go right here. If your input is 1, you go right here. If your input is 0, you stay right here. If your input is 1, you go right there. If your input is 0, from here you go right there. If your input is 1, you go right here. I want to build this circuit.
What's the bottom line?
1. If you put a 1 there. And we'll decide, maybe I'll use JK for this flip. I want to build a circuit that will behave like this. I have 4 states, 0, 0, 0, 1, 1, 0, 1, 1. And I have an output, either 1 or 0. You see the output, and there's my input. Since I have 4 states, 2 to the power of the number of flip-flops, has to be greater than or equal to the number of states. So that will tell us how many flip-flops we're going to use. How many states do I have here? 4. So 2 to what power is going to make it greater than or equal to 4? 2. So I will need 2 flip-flops. And I'm going to use JK. No reason. First thing that came to my mind, JK, because I looked, that sheet was right in front of me. That's why I use JK for that. So to design that, I have to draw the table and see what my options are. So before we get to that, we have Q1, which is state 1, and Q2, state 2. Not like state 1, 2 digits, this and that. This is 1 and 2. See them? 1 and 2. 1 and 2, 1 and 2. That's what I meant by Q1, Q2. If it's 0, 0, we're talking about that state. You also have what? 1 input. And that's what? You want to call it X? So this is the input here. This is the current states. Q1, Q2 are the current states. This is X, my input. My output is the next states. What is Q1 asterisk and Q2 asterisk? Also says Z is my output. Is it 0 or 1? You can see that 0, 1, 0, these are the outputs. Now if I am at state 0, 0, and my input is 0, according to this picture, what happened? You stay there, your next state, right? And do you have an output? Yes, 1. But if I am at state 0, 0, and my input is 1, where do you go? to 1, 0. Is there an output there? 1. If I am at state 0, 1, and my input is 0, 0, 1, and 0, you go where? To 0, 0, what's your output? 1. If I'm at this state and I put a 1, 0, 1, and my input is 1, I'm going to go to 1, 0, my output is 1. If I'm at state 1, 0, and my input is 0, 1, 0, I put a 0, I stay there, my output is 1. If I'm a 1, 0, and I put a 1, 1, 0, and you put a 1, where do you go? To 1, 1, and there's no output. If I'm state 1, 1, and my input is 0, see it, 0, you go to 0, 0, your output is 1. If I'm at 1, 1, my input is 1 right here, you go to 0, 1, and your output is 0. That's the truth table for it. Well, I'm going to use JK flip-flops. I need to take another look at the JK flip-flop. Because what I need to do now, figure out what do I need to connect to the J. Because this is what my current state, this is what my next state. What is J and K should be to go from here to there. So let me take a look back at the JK flip-flop. Let me hold this sheet of paper for a second. This can stay here. Let me write the JK flip-flop on a clean sheet. Q. And this is the Q next. I'm looking at that table. 0, 0, 0, that's a 0. 0, 0, 1, that's a 1. 0, 1, 0, that's a 0. 0, 1, 1, that's a 0. 1, 0, 0, that's a 1. 1, 0, 1, that's a 1. 1, 1, 0, that's a 1, and 1, 1, 1, that's a 0. Now I want you to look backward. To go from 0 to 0. Let me just draw a line so I know which one's which. From 0 to 0, I see that right here. See them? That's the current state, that's the next state. It looks like the only way that will happen let's see what J and K should be. From 0 to 0, you could have 0, 0 that will keep it there, or what? Or 0, 1. Which means what? As long as J is 0, and who cares what K is? As long as J is 0, and who cares what K is, I will go from 0 to 0. You can see the two cases right here and right here. This is the current state, that's the next state. The current state, that's the next state. When you had 0, 0, you got that. When you got 0, 1, you got that. So as long as you have a 0 for J, and it's really up to you. You can make it a 0 or a 1. It doesn't matter. That will keep me from 0 to 0. The next group, let me look at it with different color. I want to go from 0 to 1. Let's find out where the 0 to 1 is. 0 to 1. I see 1 here. See it? And I see 1 here. This is Q, and that's the next state. Q and the next state. It looks like it, what? 1, 0 will do it, or 1, 1 will do it. So as long as J is 1, and who cares what K is? Next, let me do the 1 to 0. Where's the 1 to 0? That's this case and this case. See them? The two in red. 0, 1 will do it. 1, 1 will do it. Isn't that don't care and 1? And the last one, it's 1 to 1. 1 to 1, that's this and that. 0 and 0 will do it. 1 and 0 will do it, don't care, and 0. Now bring this one back. Here's the first flip-flop. Let me take a look at it. Some highlighters. Purple color. Purple is gone. Okay. So let's look at this one and compare it to that one. That's the current state, that's the next state. So let's see what is, this is J and K now. What is J1 and K1 should be? 0 to 0, let's look right here. 0 to 0, 0 and don't care. 0 to 1, 1 and don't care. 0 to 0, 0 and don't care. 0 to 1, 1 and don't care. 1 to 1, don't care and 0. 1 to 1, don't care and 0. 1 to 0, don't care and 1. And 1 to 0, don't care and 1.
Can you go move it up a little bit?
Yep. Now I'm going to do another one for the second flip-flop, J2 and K2. And that's when I was looking for my marker, the different color. I don't have it, so I'll just do this. Look right here and compare it to this one. It's easy to lose track where you're looking. I need to slide it down because I have to look at that table. 0 to 0. 0 and don't care. 0 to 0. 0 and don't care. Huh? Because it doesn't matter if it's 1 or 0. 1 to 0. Don't care and 1. 1 to 0. Don't care and 1. 0 to 0. Don't care and 0 and don't care. 0 to 1. 1 and don't care. 1 to 0, don't care and 1. And 1 to 1, don't care and 0. Now I'm ready to design them. I'm ready to build my circuit. I just got to do a true Kmap for this, Kmap for this, Kmap for this, Kmap for that, build it, ready to go. We got time. So let's do a Kmap Kmap for the first one, we'll do J1, then we'll do K1, then J2 and K2. Well, you know what? Let me save that nice sheet. So a Kmap J1, K1. We have three inputs. Q1, Q2, and X. This is for J1. We have one for K1. We have one for J2. K2. And let's go back and fill them in. J1, 0, 1. That's the J. I'm doing the J. 0, 1, 0, 1. Don't care, don't care, don't care, don't care. K1, don't care, don't care, don't care, don't care. 4 of them. 0, 0, 1, 1. J2, 0, 0, don't care, don't care, 0, 1, don't care, don't care. So 0, 0, don't care, don't care. 0, 1, don't care, don't care. K2, don't care, don't care, 1, 1, don't care, don't care, 1, 0. And let's read each one, then we'll build it. Since I'm only have to group the ones, so if I take these 4 ones together, better than just taking 2 ones. And that'll be what? X. This one here, take that together, and what do you have? Q2. This one, that'll be what? Q1X. This one, that'll be what? Q2 plus, if I group these guys together, X. I could just took this one with this. X naught, yeah.
Could you just take the 2 middle columns of that last one?
The last one?
Oh, wait, never mind.
I could just group the zeros here. You know, I could have took this with that, group the 0, and they'll give me the same thing. X is 1. You complement it, and Q. If I take these 2, it'll be Q1 naught. So that's Q1 naught. Oh, I read the first one wrong, right? Here, that should be Q1 naught, isn't it? For the first group. That's Q1 naught. It's a 0, complemented. And this one is X complemented. If you took, by the way, these 2 here, if you group these 2, if you decide to go group the zeros, because you can take these 2, what do you have? Q1 being 1, so you complement that, or X complement. Yep, same thing. So now I'm almost ready for my flip-flop. I got to build it. Bring the flip-flops. I need 2 of them. So where is that sheet of paper that I saved? Here we go. Oh, I need to make one also for the output, which I forgot to make. Another Kmap for the output to see when do you get a candy, when you don't get a candy. This is for Z. 1 1 1 1 1 0 1 0. If you just group the zeros, the same thing. That'll be what? Q1 naught or X naught. That happens to be the same thing as one of the gates we just did. Q1 naught plus X naught. And now I just gotta build them, connect them. Now I'm ready to go. I have a ruler here, make it nice and neat. Now I gotta build them. I have two flip-flops, J and K. We're using right J and K. Here we go. There's one of them. I don't know why I'm using line paper. I should be on the line, but I'm not. That's the second flip-flop. I can put them one after the other. I can put them next to each other. It really doesn't matter. I'm putting them like next to each other, on top of each other. I could have put them one after the other to get the first digit and the second digit. We just run wires to the light anyway. This is JK number 1. This is JK number 2. That means this is Q1 and this is Q1 naught. This is Q2 and this is Q2 naught. This is J for the first one. We'll call it J1. This is K for the other one. I mean for the same one, K1. This is J for this one, J2. This is K, which is K2. We might have a clock here. I don't know how the clock is on the falling edge, rising edge, doesn't really matter. So it depends on how they come. So there'll be a clock running this way. To make sure they're in sync, not one going up, one down, different times. Doesn't make any sense. We have to make sure they work with the clock together. So this is the clock, CLK, clock. So they'll be synced together. They rise at the same time, they fall at the same time. Now let's look at J1. What are you going to attach to it? Just X. We have an external input, X. We have a switch. You and I are going to be flipping in the lab. That's the only input we have, is that switch. One input. When you look at this, we have three inputs. Q1, Q2. These are these. I don't control them, these. I only control that switch, the external switch. It's either 0 or 1. So now I'm going to have X, my switch here, and that's what J1 is attached to X, to that switch. K1 is attached to what? Q2, right? So I'm going to take the output of this, feed it to this one. I'll just go diagonal here. Run a wire there. And that's what K1. K1 is whatever this, you just run a wire from here to there. J2 has to be an AND gate with Q1 and X. An AND gate with Q1 and X. Let me push it back just a little bit, the X. So you're going to take an input from here, right there, feed it through this, and the other one from Q1. Take one, wrap it around here, wire, another wire. That's J2. What's Q2? K2. Q1 naught and X naught. It's an OR gate. Q1 naught and X naught. This is X. Q1 naught, that's this guy right here. So I gotta run another wire all the way around. Bring it down this way. And feed it all the way down. And the other one, I'm going to take one from X here, put a knot on it, and feed it to this one. And in the lab, to see if it's working, you take Q1 to one of the LEDs here. You take Q2 to the other LED, and you watch them to see as you're playing with X. Look at the state where you are, see if it's doing what it's supposed to do. And you also need to have one for your output X, and your output X happens to be Q1 naught plus X naught, which is this gate. So this is my X, my output. If it's candy, whatever it is, soda, cigarettes, whatever the case is. That's Z, your output. Same gate. And this circuit will do actually what that diagram that you saw there. So your output is controlled by only this switch that you have here. You're just playing with it and whatever the current state is. Now before you start anything, maybe you want to make these guys 0. Maybe you want to clear them. You tap the clear key first, you make it 0. Then you move it back to 1, it makes this one 0. You hit a 0, move it back to 1, it makes that one 0. You can start with that. Then you start playing with it and see what will happen.